Hi, my name is Manuel. I'm working at ICOCA in Vienna as a quantum physicist, and I did my PhD here from 2015 to 2020 together with Anton Zeilinger. So what I did in 1989 is a very good question. I was 4 years old, so honestly I don't remember exactly, but what I do remember is that I was in kindergarten, and I really actually loved kindergarten because it's like going to the lab here. You have lots of toys and you play around and just do interesting things. The challenge of my project is how to create higher dimensional multipartite entanglement. So what is quantum entanglement? We can think of quantum entanglement by looking at this dice, for example. So actually we need two dice. And we imagine now that these two are quantum dice and that they are maximally entangled. So a dice, usually if we roll it and we look at it, it always shows a random result. But if this one shows randomly a 3 and it's connected or entangled with another dice, we know no matter how far this other dice is apart from the first one, that it also will show a 3. It will always show exactly the same result. That is quantum entanglement. So the question that I answered, or we answered in our project, was how can we entangle many of these dice all together perfectly in an experiment? So the question was how to come up with new experiments that can create such states. And the way we did it is we asked a classical computer program which randomly tried many different configurations of the experiment and gave us different new ideas. That's the solution to this problem. When we found out how to manipulate and create higher dimensional entanglement, the coolest finding was that we found how to actually teleport higher dimensional quantum states. And quantum teleportation is not quite the same as teleportation in Star Trek, but it's similar. So we don't teleport energy or matter, but we can teleport quantum information. So we can copy the quantum information of one system perfectly to another system. It was always clear how to do this in theory, but in our new experiments, we found actually how to do this in practice in an experiment. So my research is very closely connected to quantum technologies, for example, quantum computing, quantum metrology, or also quantum key distribution. And therefore, I think it will definitely have an impact for quantum technologies. So for example, for quantum key distribution, which allows us in future to have perfectly secure communication systems, which is especially in the age of the information very important to protect private data such as health data and so further. So what my friends think about my research, so I have been in exactly this lab with many of my friends and they are all quite impressed of what we're doing. There are many open questions in my field and I don't even know where to start with. But one particularly interesting question is regarding the efficiency of the high-dimensional teleportation protocol. So the success rate or efficiency scales with 1 over d, where d is the dimension of the dimensionality of the system. So if d is high, let's say 1 million, then you need to try on average 1 million times in order to succeed with the teleportation. And that is actually very bad. So the question is whether there exists a law in nature that forbids us to do more efficient teleportation, or whether we can find another scheme, not the one we did, but another one which is actually much more efficient. So that's a question that keeps me awake at night. I can remember when I was 13, it was all over the news in Austria that the first teleportation experiment by Anton Zeilinger in Innsbruck succeeded. So I was sitting at home in front of the television and watching TV, the evening news, and Anton was explaining that they just succeeded in teleporting the first quantum state. And I was like, wow, that's really interesting. But I honestly never dared to think that I could ever do something similar or contribute to something like that. I actually wanted to become a firefighter, which I did. But on the other hand, I also became a physicist, which I think is really cool.